Today's video is looking at types of triangles. So again, this might be a little bit of revision, but there might be a few little bits and pieces that you haven't heard before, which may help your understanding moving on to the angle rules. So key bits of key bits of information is that when we're looking to name a triangle, we're looking for two things. We are looking at symmetry and the angle size, and these basically group the triangles together. So if we take a look at symmetry to start with, is that if we have a triangle, a three-sided shape, that has one line of symmetry, three lines of symmetry, or no lines of symmetry. So this triangle here has only one line of symmetry. If I draw a straight line through the middle, it creates a mirror line that it's the same on both sides. I could fold that in half on a mirror line and it would match up at every point. These points here are the same distance from the mirror line. And these lines have two sides that are equal. And the third side is a different length, but also they have two angles that are the same size as well. Now, a triangle, and that's called an isosceles triangle. A triangle that has three lines of symmetry looks like this. It has a line through each of its corners and the opposite side, creating the same thing, that each one of those is a mirror line. If you folded them on those lines, they would match up exactly the same. But also that each side is the same length and each angle is the same side as well. We call this triangle an equilateral triangle. Now, a triangle that has no lines of symmetry, in other words, an angle like this, I couldn't put a mirror line in that where it would be the same on both sides. A triangle like this has no sides that are equal and no angles that are equal, and it's called scalene. So symmetry is a really good way to work out and know a bit more information where we know about whether how many sides are equal and how many angles are equal. The other thing you might notice with me doing my notation, just taking away all the lines, is if I want to represent sides of the same length, we tend to put a dash over the lines. So the ones where there are two, all it means is that this side is the same length as this side. On our three-sided equilateral triangle, we can signify that all the sides are the same length. The other thing that we can do to show that all these sides are different lengths is give them three different notations. We don't tend to do that if they're all different, but for this case we can show that each one. So each knot just refers to try as a label rather than any sort of length measurement. So that's symmetry. The other thing we talked about is the different types of angles, is looking at an angle in it. So an acute triangle, so this is an acute triangle, and what that means that all angles are acute. So in other words, all of these angles are less than 90. So an equilateral triangle is an example of one acute angled triangle. The other one's a right angled triangle, where we have at least one 90-degree angle. So one of the three angles is 90 degrees, and the last one, you can probably guess it, is an obtuse angle, which there is at least one obtuse angle, which is a angle greater than 90 but less than 180. So we've got these two things, symmetry, and then we've got the angle. So between these, we can start labeling these together. There's a exercise in your lesson for today. So if you could move on to that and then have a crack at the questions and answers.